We started a new chapter. And for the most part, what we talked about should have been a review, right? But maybe the way I talked about it, slightly different words, a slightly different way of using the stuff that you've been done before, but you should have done almost everything you did before. So my tip for you guys, when you do the assignment today, have your notes out. Because there's lots of different things that you're asked to do. It's hard to keep that, all that information tracked in your mind. For example, right, like I said, hey, turning a fraction to a decimal. Is it top divided by bottom or bottom divided by top? Top divided by bottom, right? You gotta remember that, right? So this is calculator questions, right? And for the most part, it's fairly easy. You just go top divided by bottom. But what if I give you, let's see, a new question here. Let's go draw here. And I go, what is the decimal of, say, 3 2/5? What would you do? Diane?
Shoot myself. 3.4 just makes me and look at 2 divided by 5 and make 5 and 6.
Excellent. So what we have here is two different ways, and Diane picked it the way I think I was personally do with my mind. We have a number that's 3 and a bit. So our answer is going to be 3 point something. Right? So then you go 2 divided by 5 on your calculator and you get 0.4. So the answer is 3.4. Right? So if you want to check, I grab my calculator here. Right? Right? So there will be questions like this. That's kind of maybe like throw you off. Like we talked about decimals, right? But some of them are a little bit trickier. So that's 3.4. All right? Or the other way is, if you don't like it, is you could turn this into an improper fraction. You could say 3, so when we turn it to improper fraction, remember the denominator stays the same. So you go 3 times 5 is 15. 15 plus 2 is 17. Then you go 17 over 5. Hopefully we get the same answer. 17 divided by 5, 3.4. So two different ways. It's whatever your mind finds easier. And you should know both ways. Because next year what's going to happen is there'll be some tests that you are not allowed to use a calculator on. Some tests you're allowed to use a calculator on. So one method might be easier with a calculator. One method is easier without a calculator. Right? So you got to be able to sort of do both of them. All right? All right. So we talked about converting last day. So now we're going to do just little add-ons to that. So the main thing before I flip over to the next page is when we converted numbers from a fraction to a decimal, these two numbers were the exact same value. They weren't different. They look different, but they have the same value. Right? So same with these ones. When we converted it from a mixed fraction to an improper fraction, they look different, but they have the same value. We checked with our calculator with all of these things. So we're going to go over here. All right. So I'm going to sort of jump around this page. The first thing is with these circles on the middle of the page here on this side. I want to write the fractions for these. When you're running fractions, we have a number on the top and the number on the bottom. For this green one, what would the number on the bottom be?
8.
8. So the green one is what the total is, how many pieces there are. Here there are 8 pieces. Your top one is what you're counting. And if I give you diagrams like this, I didn't tell you what to count, but I expect you to know what to count. Are you counting shaded parts or the white parts?
The shaded.
Shaded. It's always shaded unless I say otherwise. So in the first one, we've got 4 pieces, right? So 4 over 8. All right? And the next one, what would the fraction for the pink circle look like? 3 pieces shaded, total of 6. The next one off that, the next green one, what would that fraction be? 2 over 4. And the last one, blue one, 1 out of 2. Right? So now, we have 4 fractions there. They look like they're different, but from the diagram, you can actually tell that those have the exact same value. Right? So each one of these fractions is half a circle. Right? So they have the exact same value. So when we have fractions, sometimes it's not easy to tell if things are the same or if one number is bigger than the other. So what we do is when we do our calculations, at the end, we reduce fractions, the lowest terms, so that we can easily compare numbers and stuff like that. Because the same value can have lots of different fractions for it. So to avoid that, we reduce fractions. So that's up here. So when simplifying fractions, they are reduced to lowest terms. Okay? So I'll see if you remember that from last time. So if I wanted to reduce that fraction 8 over 12, what do we do? Do we add, do we subtract, do we multiply, do we divide? What do we do?
Divide.
We divide. And we divide the top and the bottom by the same number. So you go, okay, what number can both 8 and 12 be divided by? Nina? 4. Right, so we go divide by 4 here, and we divide by 4 here, and we write out the new fraction. So 4 fits into 8 twice, and 4 fits into 12 3 times. Right? So, to simplify a fraction, we simply divide the numerator and the denominator by the same number. Right? The key, same number. Why? Because it keeps the value the same. If I took my calculator and went 8 divided by 12, grab my calculator, 8 divided by 12, and 2 divided by 3, it's the same number. Right? We're reducing it for different purposes later on. Right? So we're not changing the value. So the next one here, we have 15 and 25. What's our number that we can divide both 15 and 25 by? 5. Right? So now, if you're good at multiplying, that's why we do so much of these practices, this part is not too bad for you. If you struggle with multiplying, this is probably the hardest part of this chapter for you. It's like, how do you know what fits? So then you have to do like sort of a guessing game. So 5 fits into 13 3 times, and 5 fits into 25 5 times. So 3 over 5, right? So here's my tip for you guys. Sometimes you have to do a little guessing game, right? So you have to guess. If both of your numbers are even, try dividing by 2, 4, 6, and 8. If your numbers are odd and you can't figure out what divides, try dividing by 3, 5, 7 on your calculator. If it works, your answer will be a whole number. If it doesn't work, your answer will be a decimal, right? So just, if you can't figure it out, guess at the number and just try. And I'll help you in your assignment if you're there. So, simplified fractions. The key thing is they have the same value. We're not changing the value, right? They equal the same thing. So they're called equivalent. Remember, that's what the word is. Equivalent. There we go. All right. Okay. So now, let's put this to work. So if I ask you to give me, for this 4 over 6, another fraction with the same value, in other words, equivalent fraction with the same value, what would it be? So I have 4 over 6. Give me a, sorry?
2 over 3.
Yeah, it works because you divided the top and bottom by 2, right? So he goes, okay, I divided this by 2, and I divided this by 2. I got 2 over 3. Now, what if I say, give me another one? You can't divide it anymore because it's already in lowest term. What else could you do?
Multiply.
You can multiply. Long as the top and bottom are changed by the same amount, by multiplying and dividing, they still stay the same. So now, you can multiply by anything you want. My suggestion is pick numbers that are easy. For example, multiplying by 2 is an easy thing to do. You could multiply by 2, top and bottom. That's 8 over 12. Or, the one I like the more often doing is multiplying by 10, because that's 40 over 60, right? There's infinite ways of doing this, all right? But you just gotta realize that you can divide and multiply. right? And this achieves lots of different purposes, right? One reason we may want to change how our fraction looks is for when we want to add. Because the rule is for when we add fractions, look over here. When you add fractions together, which we'll talk about in a couple of lessons, the bottoms need to be the same. You need to have a common denominator. Right? So there's lots of times we want to change how our fraction looks. Not change its value, but change how it looks so we can do a calculation. Right? So one of the things we want to be able to do is it's helpful when we add or subtract fractions. Right? So if we have 3 over 4 and 2 over 3, we want to make the bottoms the same, the common denominator. We need to know what number can both 4 and 3 fit into. What would that be? Winter? 12. So to do that, we go over here. I want to make this 4 turn into a 12, so you start with the denominator first, after times it by 3. Because 4 times 3 is 12. And to keep the value the same, I do it to the top as well. So I have 9 over 12. And you do the same thing to the other side. You go, okay, I want to turn this 3 into 12, so I have to multiply by 4. And I multiply this by 4. And I get 8 over 12. Okay? So now, we'll talk about adding fractions in a couple of days, but they have a common denominator, we can add them. But another thing we can do is once the denominators are the same, which you're going to have to do a lot of it, is you can compare numbers. So you had a question in your last test of the exponents, and I said, hey, rank these from smallest to biggest to smallest, right? That's a very common question. So you can get that question so many times. And probably on the next test, I can give you a bunch of fractions and say, hey, rank them from smallest to biggest. Right? And if I give you a fraction like this, 3 over 4 and 2 over 3, it's hard to tell which one's bigger than the other. However, if the denominators are the same, you can tell 9's bigger than 8. Right? So it gets used in strategies for when you want to compare fractions as well. Compare. Right? So change each fraction for common denominators so they have the same denominator. Remember to multiply both the numerator and denominator. And I just realized I think we forgot to fill in the blank over here. Right? And this one here. So if you want to talk about equivalent fractions, as long as both the numerator and the denominator are multiplied and divided by the same number, things stay the same. Right? So we should fill that one in. As long as we multiply or divide both by the same number, these fractions stay the same value. All right? We're not changing the values, we're changing how it looks so we can do other math with it. We can compare it, we can add it. There's other things we can do with it. That's all. Right? So we're manipulating the situation. So let's go back to here. All right? So suppose with this 2/3 and 1/2, I want to make the bottoms the same, common denominator. What number can both those fit into? 3 and the 2?
6.
6. Thank you. So the left one, we want to turn the 3 into the 6. We go times 2 here. Because that gives us 6. Top and bottom. So that's 4 over 6. The other one, what do we multiply over here?
3.
3 times 3. And you get 3 over 6. Okay? So now, with these first two examples, gosh, we're paying attention, right? All right. Common denominators aren't easy to figure out. Sometimes they are. If you can't figure out what the common denominator, there's a trick that always works. That trick is you multiply by the opposite one. So here is a 4, so I'm going to multiply this one by the opposite side. So 3 top and the bottom. Over here, I'm going to multiply the opposite one, 4. That will always work. Right? But there's a problem with that method. Right? Because sometimes it gives you a really, really big number. For example, in the next one over here, we could, to figure out a common denominator, multiply by the opposites. We'll multiply the left side by 12, and we'll multiply the right side by 8. It will work. I will not mark you wrong if you do that. It is a strategy, and it's a valid strategy. But you end up with bigger numbers. So if you're not good at multiplying and you can't see what the common denominator is, here's a technique. I mean, for my grade 8 class, we talked about it last year. You can use your multiplication chart. Okay? You have one on the back of your notes. There's one on the back of your assignment. You find your common denominator. Oh, sorry, your denominator. So we have 8 and 12. And these are all the multiples of 8. These are all the multiples of 12. You want to find which ones do they share in common. So they share 24 in common. They share 48 in common. They share 96. They share a lot of things in common. All of those denominators will work. You can pick any one of them. But to make life easier and calculations easier for us to do, we pick the smallest one. But all the other ones are valid. So here we go. Okay, the smallest one is 24. So we're going to multiply the 12 by 2, and we're going to multiply the 8 by 3. Right? So if you're not sure, you can use your multiplication chart. So go over here. Who's seen that before? Only a couple people. All right. So go back here. So you want to make both of them 24. You know, so this one is 12 times 2 is 24. Top and bottom. So we get 14 over 24. And you multiply this one by 3 top and bottom to get 24. So we have 24 and 15. All right, so all these little things coming all together, okay? All right, so one last thing. So for the most part, you've done everything here. I'm using different words maybe in the last year. The new word for this year is the word rationals. So remember, rationals is just a fraction. So sometimes a very common multiple choice question is, hey, can you tell me which numbers are rationals? And where students go wrong is if I give you a list like this, and you go, students usually go, okay, this one's a fraction, so this one's a rational. And this one's a fraction, so it's a rational. And this one's a fraction, this is a rational. And they get some of the marks. They don't get all of them. There's a little bit more to that definition. So a rational is not just a fraction, but any number that can be turned into a fraction. All right? So, for example, 9 is the same thing as 9 over 1. So that's a fraction as well, right? Or this one, this decimal is also a rational. 1 over 3. 1 divided by 3 is the same thing as 0.3 going on forever. So all of these are rationals, right? So any fraction, any number that can be written as a fraction. So A over B. And for you guys in your math education so far, almost every single number you ever worked with is a rational, except for the number 5. Right? So next year or the year after, you learn about the opposite of rationals. They're called irrationals. There's some numbers called that, and you learn that about later on. Right? So by default, if you're not sure, the answer is going to be yes. It's a rational. Okay? That's your default answer. All right? And that's it. And hopefully